For Chapter 2, Question 14, they're asking you to write the numerical value for each of the following prefixes. So the way that the metric system works is you have a few base units, so these units up here, they're called base units, and they describe basic features of reality, things like length, or mass, space, time, or temperature. And there's a unit that's a reference point used for those things. So for length, it's the meter. For mass, it's the gram. For space, it's the liter. For time, it's the second. Sometimes that works out very nicely, those units. For example, a meter is about 3 feet, and if you wanted to measure a person or a table, a meter would be a good unit, because you won't get some crazy number. You'll get maybe 2 meters or 7 meters, but nothing insane. If you wanted to measure the distance from Florida to New York, though, you would get thousands and thousands and thousands of meters, so that the number would be kind of awkward or cumbersome. And so it'd be nice to create a new unit based on that base unit, the meter, that would let you have a smaller, more manageable, more intuitive number. And so what the metric system does is it takes that base unit and it either multiplies it by 10 or divides it by 10 to get a unit big enough or small enough so that the measurement you have has an intuitive, straightforward number attached to it. Now those prefixes that do that are here. And you can see what power of 10 each of these prefixes are multiplying the base unit by. So tera, this capital T, is multiplying the base unit by 10 to the 12th. So a terameter would be 10 to the 12th meters. A gigameter would be 10 to the 9th meters. A megameter would be 10 to the 6th meters. A kilometer, or a kilometer, would be 10 to the 3rd meters, and so on. So there's a number value associated with each of these prefixes. It's the number that you multiply the base unit by. So in this first one, it says write that number value for each of the following prefixes. Now the first one, giga, we saw the process you'd want to go through here is to look at the symbols, or in this case, because they're giving you the name, you can look at the prefixes. So look at the prefixes. Once you see giga, we're going to stop. Okay, so here it is. And then we're going to look for the numerical value. Now, you can see they have numerical value here, and it has a lot of zeros in it, but it's kind of awkward to have all those zeros. It's not as clear. First, if you try to count the zeros, they kind of mush together in my mind anyway. So and it also takes time to write all of those zeros. So an easier way to write that number is 10 to a certain power. So 10 to the 9th power is telling you that you're going to take the decimal point here and move it over 9 times. So 9 times until you get 9 zeros. So 10 to the 9th and 1, 0, 0, 0, 0, 0, 0, 0, 0, 0 are the same number. This is just maybe a more convenient, concise, clear way to write that number. And so here, when they say, what's the numerical value for each of the following, you could write 10 to the 9th. 10 to the 9th. And so, for example, if you had 1 gigameter, what that really is, you can take that giga prefix and say, actually, it's 1 times 10 to the 9th meters. So those are the same thing. So that equals 1 giga meter. So that prefix is really just standing in for that number. Okay, so similarly, how about with micro? So again, we're going to go back to this table 2.4, and we're going to go look at the prefix. We're looking for micro. We won't stop till we see micro. Ah, here it is. Okay, so there's micro. And also, while we do this, just keep in mind that there are 2 parts to this table. There are prefixes that make the base unit bigger, and prefixes that make the base unit smaller. So keep that sort of in a conceptual, to use that to sort of frame what we're doing. Are we making the unit bigger? Are we measuring a big thing? Or are we measuring a small thing? So micro, you can see, makes the unit smaller, decreases the size. And so micro is going to be a small thing. Now the number associated with it is either this number or, and maybe more clearly and concisely, 10 to the negative 6th. So you could just write 10 to the negative 6th. But what that means is that if you had 1 micrometer, you could take that, and that micro prefix is really just standing in for 10 to the negative 6th. So 1 micrometer, or micrometer, is 1 times 10 to the negative 6th meters. That's a millionth of a meter. And so that's what that prefix is telling you. Notice that the base unit could change. The prefix only tells you what you're multiplying the base unit by. So right now we're using meters. You could just as well use grams. 1 times 10 to the negative 6th grams equals 1 microgram. Okay, C, mega. So mega, we'll look at the prefix here on the left. Once we see mega, we'll stop. Ah, here it is. Okay, so the number we're dealing with is this right here, that number there, but maybe a clearer and more concise way of writing that number is 10 to the 6th. So 10 to the 6th is what mega is standing for. And just to drive that home, what that means is that when you have 1 megameter, but just to prove the point that you can use different bases with each of these prefixes, I'm going to use a gram. So, for example, 1 megagram, what does that equal? Well, that would equal, because mega is just standing in for 10 to the 6th, 1 megagram would be the same as 1 times 10 to the 6th grams. So 1 megagram is 1,000,000 grams. Okay. Last but not least, nano. Now, you've heard of this probably with like nanotechnology or the nanoscale. When they're talking about nano, what are they talking about? Nano is giving you a reference for how big something is. And so here, we'll use this prefix. We're not going to stop till we see nano, and here it is, nano. The number associated with that is this, so it's pretty small. A concise way of saying it is 10 to the negative 9. So the prefix nano is another way of saying 10 to the negative 9. So for example, if you had 1 nanometer, or nanometer, 1 nanometer, or nanometer, what is that? What does that even mean? 1 nanometer is equal to, the nano is just standing in for 10 to the negative 9th, so that would be times 10 to the negative 9th meters. In other words, a nanometer is a billionth of a meter. If you took a meter, which is more or less 3 feet, and you break it up into a billion parts, one of those parts would be a nanometer. So each of these prefixes in your mind, you should have with, like, when you look at them with your X-ray chemistry genius vision, you would see these numbers associated with them. And you'll think of the base unit as either becoming bigger or smaller, depending on what the prefix is.